In question 2a, we're solving the polynomial by factoring. Now this is a fourth-degree polynomial, which we really haven't dealt a lot with. So what we said we can do, if we have a fourth-degree polynomial that is quadratic in nature, in which this exponent is twice the size of the other exponent, then we can rewrite this by using some substitution principles where we allowed u to equal the smaller of the two exponents, x squared, which meant u squared would have to equal x to the fourth. And we made those substitutions so that we could get it looking like a quadratic. So instead of an x to the fourth, we have an u squared taking its place. Instead of an x squared, we let u replace it, minus 20 equals 0. So now this is our quadratic equation, at least it's quadratic in nature. So we can solve this quadratic equation just like we've done all the other quadratics. We had three good techniques. We could factor, we can complete the square, or we can use a quadratic formula. This one is relatively easy to factor, and our leading coefficient here is 1, so when I encounter those, I try to at least factor. The u squared has to be u times u. The signs have to be different. One's plus and one's minus. And the factors of 20 that are 1 apart are 5 and 4. So we end up with a u plus 4 times u minus 5 has to equal 0. Well, if we have two numbers that are multiplied together and their answer is 0, then one of these numbers must equal 0. So we know that either the u plus 4 is 0 or the u minus 5 equals 0. Which means u would then have to equal a negative 4, or our u would have to equal a positive 5. We got to go back and replace what u represented. U represented an x squared. So now we know that x squared equals a negative 4, and then we're going to solve that for x, which means x equals plus or minus the square root of negative 4, which is plus or minus 2i. So there's two solutions that we have already. The other one, we've got to replace u with x squared again. And we're going to do the same thing. We'll square root both sides, so it's plus or minus square root of 5. And there's no perfect squares in 5, so those are our other two solutions. So we have four solutions for that fourth-degree polynomial. We found them through treating it like a quadratic equation.